right, let's look at linear regression output. This is what you're going to be doing in the beginning of Unit 4 in 4.1. You're going to be taking some data, some XY values, and you're going to be creating a line that best fits those data points. So what I want to do today is just talk to you about how to interpret the output from StatCrunch so that you'll be ready to answer the questions when it's time. So let's take a look at this first problem here. And in this problem, there were like wastewater measurements taken of COVID infections in the wastewater. And then they're in a city, and it says wastewater north, and I just assumed that was a northern repository of it. But anyway, they took these measurements where they measured the amount of COVID in the wastewater, and then they also measured positive new cases, and they looked to see if there was a correlation, which of course there was, between the amount of COVID they detected in the wastewater and the amount of COVID that was showing up in positive cases in the city when people were testing frequently. So here's what we have. We have output, and I want to show you some information that'll be important in the output. I'm going to highlight these, and then I'm going to erase the highlights so that you can read it better. But one of the things that you're going to look at in the output is the equation of the line, and that will be found in this first box here of output. The other thing you're going to look for is the correlation coefficient. And then the third thing you're going to look for is the slope. The slope can be found a couple of places. It can be found in the equation, but it's also right here, if you want to pull it from there and look at it from there. Either place, same number, same value. It's the slope of the line. So it's the slope of this line that we've been given over here in this picture. Okay, so I'm going to erase these marks, like I said, so it's easier to read when we try to read it. Okay, so identify the independent variable. We have an independent variable and a dependent variable. And the way I always think of it is the number of new cases depends on what the wastewater showed. They're measuring the wastewater, and they want to see if that independent variable of measuring the wastewater will predict a dependent variable of how many people really tested positive for COVID. So, for some reason my paper won't scroll up. There it goes. Sorry about that. Okay, so identify the independent variable. The independent variable would be the wastewater. Measurements. And the dependent variable would be the positive new cases. Because here's the deal. If they can find a correlation between those two, then all they have to do is measure the wastewater, and that gives them a good prediction of how many positive cases are in the city. So that's why they ran this test. So write the linear equation of the line of best fit. The linear equation is right up here. And we're going to use X and Y instead of the words. So Y is the dependent variable. That's the positive new cases. So Y, and I'm going to call it Y hat just because it comes from sample data. So Y is equal to 929. I think I'm going to round to one place on that intercept. Plus, notice back up here on this equation, here's this plus 929.8 plus 2.83 times the wastewater measurement, which is x. So that's how you rewrite the equation using y and x instead. So that's the equation of the line that we have from the picture there. Is this linear relationship positive or negative? Give 3 justifications. Every time you're going to give 3 justifications, and I'm going to use the same wording for each of those. So the first would be correlation. Oh, my phone's ringing. Sorry. Correlation coefficient. The second way we're going to justify it is by looking at the slope of the linear equation. And the third way we're going to justify it is just by looking at a visual inspection of the graph. Okay, so the correlation coefficient, when I look back up here, the correlation coefficient is 0.85217. So I'm going to write that my correlation coefficient is I'm just going to call it RC. And I know that in your output, it's a capital R. The linear correlation coefficient is almost always identified as a lowercase r. So I'm going to call it a lowercase r instead. So I'm calling it lowercase r with a subscript of C is 0.85217. 0.85217, so it'll be just 22. Okay. The slope of the linear equation, let's look back at it. The slope is given right here in the equation. It is also listed in the output. And you can look right here and see your slope is also right there, 2.83. So I'm just going to say that my slope is 2.83. And now a visual inspection of the graph. My graph is heading up as I read from left to right. As the wastewater increases, so does the positive new cases, which makes sense. The more COVID we're seeing in the wastewater, the more COVID we'll see in positive new cases being tested. So my graph is actually heading up. So when I look at this, my correlation coefficient was positive. My slope of my linear equation was positive, and my visual inspection of my graph, this is a positive relationship. As I go up with X, I head up with Y. So that's also positive. So I would say the relationship is positive. Now, for the last one, we're going to do some computations. And we're going to, I give you a couple of X values and ask you to compute Y. And then I give you a Y value and ask you to compute X. So we're going to use that equation that we've gotten, and we're going to do these computations. So the first one, X is 4,300, which means whatever that measurement is in the wastewater, it has a measurement of 4,300. So I would say that my number of positive cases, Y hat, is equal to 929.8 plus 2.83 times 4,300. I just plugged in that X of 4,300. And so that means my Y is equal to 13099. That's what I have written down. I'm questioning that, so I just want to look back at my answers. Yep, that's it. Okay, so then second one, y hat is equal to, again, 929.8 plus 2.83 times 7,500, which would be 22,155 new cases. Notice that as x increased from 4,300 to 7,500, y also increased. That is another way of noticing that the linear relationship is positive, because as x increased, y increased. So we can see it's a positive relationship. So that could be a fourth way of justifying part D, is using the table. All right, now let's work backwards. I'm given y and I need to get x. So I'm going to say 15,000. Whoops. Okay, this is going to drive me crazy. Okay, you know what? I'm working outside of that box. It's because I have, I'm trying to write inside a table and Word doesn't know where to put stuff. So I'm just going to work this whole problem outside of that box. So I have 15,000 is equal to 929.8 plus 2.83, and I don't know what x is. So I'm just writing x. And that, when I subtract 929.8 from both sides, I get 15,000 minus 929.8 is equal to the 2.83x. And let's do that subtraction. I get 14,070.2 is equal to 2.83x. Now I divide by 2.83, and I get x is equal to 14070.2 divided by 2.83. And when I do that division, I get that equals 4971.8. So when I write that in over here, let's see if that table will take that. It will not. I'm going to write it down below it. 4971.8. Okay, that's it. Practice. Be glad you're writing on paper instead of writing on this iPad, because you'll be able to write in the table.